Hello, this is Ttest. Welcome to today's session. In today's brief video, we're taking a look at independent t-tests. We will demonstrate this using JASP, and as we do, we'll come to appreciate its use, especially when it comes to inferential statistics. Well, viewers, did you know that independent t-test has another beautiful name? Well, if you watch this video to the very end, you will be able to know that beautiful name that can be used to refer to independent t-test. Now, let's begin. Independent t-test, what is it? Well, it is used to determine if there is a statistical difference between the means of two independent groups. So, for example, we have male and female groups. So we decide to take the height of males and then find the mean of that height. Now we take the height of females as well and find the mean of their height. Now we ask ourselves, is there a statistical difference between the means of these two groups? Now, in order to be able to confidently say yes or no, we need to undertake what we call the independent t-test. And the independent t-test will be able to tell us if there is a significant difference between these two means. Now, in doing that, there is always a null hypothesis that is being tested. And that null hypothesis states that the population means from the two unrelated groups are equal. Now, whenever we are doing this independent t-test for parametric variables, we have to be mindful of these three assumptions. One, the fact that the two groups should be independent of each other. And so, for example, if we have two groups made up of first level 100 students and two level 200 students, participant one can either be in either of these two groups, either level 100 or 200, and never in both. By so doing, we ensure that these two groups are independent of each other. However, a situation will arise where, for example, we take the height of level 100 students in 2000, and then in the following year where they progress to level 200, we again take these same students' height. So now we are measuring the same people's height at two different instances. This is the situation we refer to as repeated measures. And when you have such situations and you want to measure the change in difference or the difference between the height, the mean height at level 100 and level 200, we would use paired t-test. Another assumption that we need to consider is the fact that the dependent variable should always be normally distributed. In our previous video highlighted how we can be able to determine whether a data set is normally distributed or not. If you have not watched that video, we encourage you to search through our channel and you would find that video very, very useful in explaining the concept of normality to you. Now, the last assumption that needs to be satisfied is the fact that homogeneity of variance needs to be satisfied, where the variables of the dependent variable should be equal in each group. Now, having established these facts, we want to go to the JASP platform and see how we can apply this knowledge practically. Good, so we are back to our JASP platform. So we click here as usual, we click on Open Data Library and we'll select t-test. Now, our interest, as we know, is to be able to see a data set that would help us demonstrate independent sample t-test. So we'll click on this and it opens a data set for us called visibility clock independent sample t-test. Now, it says that this data set, visibility clock, provides the number of mischievous acts committed by two groups of people, those with and those without, and invisibility clock. So the variables here are participants, the clock, and the mischievous acts. It's well explained here, and we will be able to know what are the variables. So those are the variables that are stated here. Now, take note of this part. It says that This example Jaffa demonstrates the use of an independent sample t-test. Specifically, we examine the adequacy of the null hypothesis that, notice, the invisibility clock has no effect on the number mischievous acts committed or the number of mischievous acts collected. Now, as we rightly established, we have assumptions that we need to check so as to see that our data is suitable for independent t-tests to undertake the independent t-test. So the first one is to ensure that the variables are independent of each other. And from what we have read at the description part of this data set, it helps us to see that the two groups are very distinct from each other. Why? Because one group is with visibility clock thing, and then the other one is without it. And so they are two distinct groups, and no participant can belong to two of these groups. So it fits for, or it checks the assumption first one. Now, the second assumption is that it needs to pass the normality test. And it says that assumption checks are not statistically significant at that. So since the Shapiro-Hicks normality test says that the p-value is not significant, it helps us to see that our data set here is parametric. You may want to watch our video where we explain how we can use the p-value at the Shapiro-Hicks normality test to explain how to tell whether a data set is normally distributed or not. So you watch that video and you'll be able to really appreciate the point we are making here. Now, the last one is to check for homogeneity of variance. And this one also states that the p-value is statistically not significant. So it helps us to see that the variance between the two groups are equal. And so it passed all the assumptions for the normality test. Now, this is the normality test part. So the student t-test, and then the watch. We can uncheck the watch. It's not needed for now. So the student t-test has been checked. And let's wait for it to load. Good. Now, this is the description of the results. It says that okay, let's check that and see what it gives us. Okay. It says that this table indicates that, or shows that let me take it again. That this table shows the output for the independent sample t-test. Both the student t-test and the watch version are shown. The difference between the two groups are not statistically significant at a level of 0.05. Why do we say that? Because when you look at this output here, the student t-test, it says that the p-value is 0.10, which means that it's greater than 0.05. And since it is greater than 0.05, it is not statistically significant. And so it does not provide a motivation to reject the null hypothesis. So we accept the null hypothesis that the population mean of the two groups are equal. So that is the conclusion we can draw about this data. I hope you find this very useful. If you intend to carry out this on your data set, you click here, and then a drop down comes, and then you select independent sample t-test, and then you are good to go. Well, did you remember that we wanted to tell you another beautiful name for independent t-test? Well, the answer is clearly stated here. Another name for independent sample t-test is what we call the student t-test. The student t-test. So that is one take home you want to always keep in mind, that the independent sample t-test is also called student t-test. We hope you enjoyed this video. We encourage you to like it. We encourage you to subscribe and to share with your friends. Until we meet again, this is Ttest, and it's bye.